It's a classic computing interview session.
Hi, everyone. Thank you for joining us. And today we have with us Alex Anderson-McLeod. He is a PhD student, and I am here to talk with him about his latest project called the Lisa FPGA Project. And it is an open source initiative to recreate the entire Apple Lisa computer architecture using a modern programmable chip called an FPGA. And Alex, welcome. First off, thanks for joining me.
Thank you.
And
Happy to be here.
You're a PhD student. I think in one of your presentations, you said you're a second year PhD student. Is that right?
Yes, I just finished my first year, and so starting in the fall, that'll be my second. Yeah.
So forgive me, I don't have a PhD. So is it 2 years then, right? Typically?
No, it's generally about 5 years.
Oh, really?
You can make it take longer if you want, because there's not really like a strict, you're not like a freshman, sophomore, junior, senior like normal college. It's kind of just however long you want it to take. If you were super determined, you could probably get it done in like 3.
Oh,
But 5 is standard. You can go up to like 10 if you really wanted to, but 5 generally.
and I won't spend too much time on this, but just for everyone's edification. But also, I guess it depends on, like, so before you became a PhD student, did you have a bachelor's or a master's?
Bachelor's. I'm just going
Okay.
straight for PhD now because I know that's what I
All
want.
right. So I guess that depends on how long it takes as well, right? If you're coming into
Yeah.
it as a master's and all right, and you go to a college in South Carolina, is that right?
Yes, the University of South Carolina.
Okay, and where's that?
It's in Columbia, the capital.
And are you from South Carolina originally, or
I am. I'm from right here in Columbia. I live like 3 minutes from the university. Always been here.
okay? And I'm in Jacksonville, Florida, so not too
Yeah.
far.
No, not far at all.
So let me finish the intro here. So the project makes the rare and expensive Lisa more accessible by replacing its complex, aging circuit boards with a single modern board that can run all original Lisa software. And so I already touched on, where you're a student, your major is computer engineering.
Yes.
And so here's my first question is what type of work will you be doing after you graduate?
Yeah, I haven't fully decided yet. Like I could go and work for, a variety of different companies. You can do a lot of different things as a computer engineer, but given my interest in FPGAs, it would be pretty cool to work for Xilinx because, well, they make FPGAs, and they're my favorite FPGA manufacturer. That's who I'm using on the Lisa FPGA board, so they'd be a pretty cool place to work for. Also, I've always liked SpaceX and everything they've been doing with Starship lately, so that would be another neat place to work. Another thing, though, that's come up more recently, just thanks to the reception I've been getting on the Lisa FPGA project here, is perhaps I could just do like freelance FPGA work for people because I've been getting a lot of offers to do that after showing this project off online. I've already taken one person up on an offer, so maybe I could just keep doing that, but I haven't fully decided yet. So it could kind of be most anything, honestly.
You're also involved in, specifically computer history related things. My advice is that you drop out of college and you start your own business and get rich. Because that's
Several
what,
other people have told me that, so you're not the only one.
well, I'm kidding.
Oh, I know. But several other people have like
That
actually
seems to be
seriously
the
told
thing to
me
do,
that.
right?
Yeah,
Historically.
I know it's worked quite a few times.
So I'm going to actually jump because I don't even, so I am not an engineer. I am not a programmer. I'm fairly technical, but not to that degree. So please, I know I'm going to put links to your own presentation you did on YouTube and then the speech you gave at the Venice Computer Festival Southwest. But can you explain what FPGAs are to just the uninitiated?
Yes, I'll try and do it in simple terms. So FPGA, it stands for Field Programmable Gate Array, and it's basically just a chip that has a bunch of logic gates and flip-flops just laid out on the surface of a chip. So basically just all the building blocks that form logic circuits. They're all just laid out on the chip, not connected to each other, just hundreds of thousands of them just sitting there, all just on the chip. And then you get to write code in what's known as a hardware description language. The one I use is System Verilog, and that code basically describes a logic circuit. And then through a process known as synthesis, you convert that code into a map of actual logic gates that are then mapped to particular gates on that actual chip. And then the gates on the chip are wired up to each other according to your design. So it's basically a way to implement any arbitrary logic circuit that you want on a chip in real time. And field programmable means that you can reprogram the chip with a new design whenever you want in a matter of seconds. So very versatile, really neat, really powerful.
So I think I get it. So let me see if I can. If you tell me if I get it. So obviously, the whole great thing about computers once they became general purpose computers is they could be programmed. So you had getting into personal computers, you had hardware and it contained circuitry, especially the microprocessor. But that was a piece of hardware. It was a fixed state microprocessor, and then you wrote software to do things with it inside its architecture. So what an FPGA does is you're writing software to program the hardware, and then now you can run software on top of that as if it was that old school, whatever you want to say it, that old fashioned type of hardware. Is that?
Yeah, that's a pretty good way of putting it. Like you can implement an entire processor inside of an FPGA and then run software on that processor. Like obviously
Okay,
I am doing that in Lisa FPGA because the Lisa has a 68,000 in it and I have to
right.
implement that inside the chip.
And
You
its
can do
software is looking
other
for
things
those.
in them too. Like
Yeah,
you don't have to implement a processor. You can also just implement logic circuits that aren't a processor, but that is absolutely something that you can do.
but it's programmable hardware.
Yes, yes, you're programming logic circuits into hardware. You're not writing like assembly language code that runs on a CPU or something.
Very cool.
Yeah,
I,
very
I
cool.
didn't until I started looking more into your project, and so I've heard of FPGAs, but then I didn't really get it. So that's cool. So leading up to where you are now in your college career, so has this always been your major and your goal, or like when you first started college, were you going a different direction in high school? Like how did you get there? Or were you always into this, or what kind of led to it?
Yeah, I've been into this for a very, very long time, like going all the way back to when I was a very young kid, like about 3 years old. My parents would try to expose me to as many different disciplines as possible to just see what I was interested in, right? So they would buy me like a bunch of different like toys and science kits and things like that to just see what I was into. And one of the things they bought me was like a really simple circuit kit around the age of 3, and that was the thing that I
Wow.
was really interested. It was really simple. It was like a light bulb, a switch, and a motor and a battery. Nothing
Yeah.
nothing crazy. But that was the thing I was really interested in. Um, and so they realized that, and they started getting me more circuit stuff over the years. Like I don't know if you've heard of snap circuits, but that was kind of
Yeah.
the next evolution of that. And then eventually I started moving into more sophisticated stuff, like Make Magazine. I don't know if you've heard of that
Yeah.
magazine,
Yeah.
but
Yeah. I've been to
that I
maker
started.
fairs.
Oh yeah, yeah. So have I. So have
I've
I.
been around for a while.
Yes, yes. No, I started getting those in maybe about 2000, no, maybe 2008 or so, and started learning a lot more about hardware through there, doing some projects from those. And then a couple years later, when the Arduino started becoming a big thing, then I started getting into software, programming, embedded hardware, all that sort of stuff. And then over the course of middle school and high school, I just kind of started developing those skills further, doing more complicated projects and just same in college, just more sophisticated stuff over time until eventually we made it here. So, no, I've known that this is what I've wanted to do for a very long time. I did start college as an electrical engineer instead of a computer engineer, but I ended up changing to computer engineering junior year because I realized that it's just more of what I wanted to do. But I have known that this essentially is what I've wanted to do for a long time.
Or were or are either your parents or were they really highly technical people, or that's not at all, or?
Far from it. My
Oh
mom has
yeah.
a PhD in clinical psychology, and my dad has a bachelor's in geology. So
Okay.
neither of them know anything about tech.
Okay, but highly educated people. So
Yes,
yeah,
yes,
so that's
but
good.
nothing about tech.
And when did your interest in like old computers, when did that sort of enter the recipe?
Hmm. Well, I've been interested in the Lisa in particular for a very long time.
Really?
Probably since I was about 11.
Yeah?
I don't I don't remember where I read about it, but somewhere I read about the system. I was just like, wow, this is such an interesting computer. I really want one of these. And then I checked eBay and I was like, okay, maybe I won't be getting one of these anytime soon. But I was really fascinated with it. And then other older systems became of interest to me just because I thought they were a really good way to learn about computing, just because they're simple enough
Mhm.
that a single person can understand the full architecture of the entire system. Yet, once you start getting modern enough, they are still complicated enough that it's a challenge, right? And that's what I liked about them. It was a long time before I was actually able to get my first Lisa. That didn't happen until I think 10th grade in 2019, but eventually I was able to get one, and now here we are. Yeah, so I had been saving up for one for quite a few years because I knew I really wanted one to learn more about it and repair one, all that sort of stuff. And I'd saved up about maybe $600 at that point, which,
Wow.
that's still, you still have to kind of get lucky in order to find a Lisa for that
Yeah.
price point.
Oh yeah.
And I eventually got lucky in late 2019. I found one on eBay for I think like $450 plus 100 for shipping. And I grabbed that thing and it
Wow.
was at my door about a week later. The catch, though, was that it was horribly battery bombed. I think it was the worst Lisa. I've seen a lot of Lisas. I think it was the worst one I have ever seen. Like,
Mm.
not even exaggerating, worst I've ever seen. And I didn't have as many tools back then as I have now, or as much money back then as I have now. So it took me a long time to get that thing working. I had to use like copper tape in order to patch up the edge connectors on all the boards. But then
Wow.
every time I'd insert them into their slots, the
I
copper
tear
tape
it.
would come off, and then I have to put it back on every single time. And I had to do that on like 60 of the pins on the connector. So it would be like a 2 hour job every time I take a board out and back in.
Uh,
So frustrating. But eventually I got the thing working. And that's kind of what led me into, designing boards and all that, because I was just so sick and tired of those pieces of copper tape that I was just like, all right, let's design some boards to replace this stuff. And that's why I designed the IO board and the motherboard first to replace the ones that were the worst corroded. And
let's talk
yeah,
about that. So, yeah, so I saw, so I'm going to put links in the show notes again about the YouTube video you made, and then from VCF, I was at Southwest,
yep.
and then a link to your GitHub where you made the Apple Lisa PCBs, right? And you did those in 23, I think so, or 22 maybe.
I honestly
I
can't
think it's,
tell you. I feel like it was a little longer ago than that, but I don't know for
oh,
sure.
you know what it is DOS Cat made that reproduction Lisa with the boards in 23. So yeah,
Ah,
you probably
yeah.
did it a little bit before that.
Yeah, I feel like it was like 21 maybe, or maybe
I'm
22.
going there. So anyway, doesn't matter.
Yeah, that doesn't matter too
In
much,
the
but
past, and there's the there'll be a link in the show notes. So you remade the motherboard and the IO board.
yes, those were motherboard was first. That was the first circuit board I ever designed, I think, the motherboard. And then after that, I did the IO board, which was a good bit more complicated, but still not an insanely complicated board or anything. And then I did some other ones after that, like I did the parallel port card,
Uh-huh.
and
Yeah, I
then I
see.
did the Sun Remarketing SCSI card, and then the accelerator, although I haven't been able to release that one, and the PFG and the LSAC, some other things like that that I can't release, but bunch
Uh,
of stuff, bunch of
yeah.
stuff for the Lisa.
So again, for those of us that don't know a lot about, so I'm the kind of person like when you're Lisa FPGA, make sure I'm getting that. I'll say PCB. And remember when I first started emailing you and stuff, I was thinking, oh, you got to get the bare board and build it. I'm like, I can't do that stuff. Who am I gonna find that can do that for me? But it's all ready to go.
Yeah,
So,
yeah.
but so people like me that aren't that technical. Oh, the
Oh,
thing.
did it? Yeah.
Yeah,
Well, it's not showing up at all.
I
But
can.
I was
I'll
trying to
put a
show the
picture
board.
of it
Okay,
at
okay.
that point. But so, for instance, say I want to get one of these boards, though, I would have to have it made and populate it myself. But it's all free and open source, but you have to make it. You have to kind of know what you're doing and make it, right? From
So
GitHub.
that's not necessarily entirely true. It's partially true, but not completely. So I give full instructions. I haven't actually made the repo public yet because there's still a few more things I need to do before we get to that point.
Okay.
But in the current README that I have full instructions for how to order them and
Oh,
all
okay. And
that.
I didn't read it, so sorry.
Even somebody who like never ordered a PCB before should be able to
Oh,
understand and
all
follow.
right.
And JLCPCB offers assembly services, so you shouldn't even have to assemble them yourself. It would be cheaper to assemble them yourself because
Yeah.
you don't have to pay their assembly fees and stuff. You just need to pay for parts, but it's still completely possible to put them together yourself if
See,
you
I'm glad I
want
asked the
to.
question because I didn't know that, so that's good to know. That's
Yeah,
really cool. And I'm thinking, this is always gonna be a niche thing, but I think there's gonna be more and more demand for this. And let's face it, the boards are, I won't get into myself too much, but I've owned a couple of Lisas over
hmm
the years, right? And different reasons had to get rid of them or sell them. But I have a Lisa now, and it was battery bombed too. And thankfully, I know a guy who I'm in Jacksonville, Florida. He's in Tallahassee, Florida. He runs a club, and he's a vintage tech on the side.
wow.
So he did a lot of work on it, and he had to replace the motherboard. And I think with your boards, an IO
Uh,
board,
yeah.
or we went to through John Woodall. Actually, I think we got him those Sapient ones, which we were.
Yes. Yes.
So yeah, so there's other people that have done it, but anyway, forgot where I was going with that. but yeah, so it's very common with this battery bomb thing. And the thing is,
Oh yeah.
if someone hadn't already clipped those batteries out a long time ago, it's pretty much the boards are ruined almost at this point. So
Very true. It is incredibly rare to find one that has the batteries on it but hasn't leaked yet.
so let's go back to so around 11, you said you became really fascinated with the Lisa, and you touched on it, but anything else like why or did it like for me it came out of being fascinated, I'll call it, but I was just in love with the Macintosh. Like when I discovered the Macintosh in the late 80s, I knew that this was the computer I wanted.
hmm
Like, I'll save my money, I'll get and then ultimately I ended up getting a Lisa because it was the cheapest way for me to get a Macintosh because it was essentially a Mac Plus, when I
Right.
done remarketing.
Yep.
So what fascinated you so much? Just it was cool looking, you think? Because I always thought it were cool looking too.
Yeah, well, I'm gonna be honest. I don't even know if I knew what the Macintosh was when I was 11. Like I knew what
Okay.
the like a MacBook was or whatever,
Yeah,
but I
yeah.
don't think I
Not
knew
like
the
that old
history.
one.
Yeah, I don't think I knew the history behind it at the time. So it certainly wasn't that. At that particular age, I think it was more just because of the historic aspect of things. It just I wanted to learn more about that weird, unique
It's
graphical user interface and just the
oh
everything strange about the computer. I didn't know enough about computing at the time to, know enough about the architecture to be like, oh, cool, it's got protected memory in 1983 and all the and preemptive multitasking. I didn't know enough about it to be interested in it for those reasons. But obviously those interests developed over the next few years as I got closer and closer to actually getting one. But at first, I'm pretty sure it was just wow, that's a cool user interface that I want to play with, and also just a cool looking computer that I would like to take apart. Because back then, I was super into taking everything apart that I could get my hands on in order to
oh yeah.
figure out how it worked. I got
Yeah, why
shot
does
by
it look
quite a
like
few
that, right?
CRTs.
Did it have the widget hard drive in it inside of it?
No, that was a 2.5 that I got because it was
Okay.
battery bomb. The 210 doesn't even have batteries.
Oh,
So
you're
yeah,
right.
but no, it was a 2.5. It had the
All
it
right,
had
cut
the
that. Cut that. I knew that, but go ahead.
it did have the 800K drive upgrade from Sun Remarketing, so there was
Okay.
that. But yeah, no hard drive of any kind. I actually didn't have a hard drive for it for several years, so I couldn't even boot the Lisa OS for like maybe 2 years after I had the thing. I could only boot MacWorks, and then eventually, because I couldn't afford like an X profile, which was pretty
Yeah,
much the only
$400
option
on
on
it.
the market at the time. So eventually I got a Cameo aphid and but then the BeagleBone computer that powers it broke. So then I was like, all right, let me just design my own, and that's where Arduino file and then ES Profile ended up coming from.
Can you tell a little bit your formal studies in college? How did that influence your approach to starting work on the FPGA?
Yeah, so to be completely honest there, I think that like don't get me wrong, I absolutely have learned things in college, like for sure. But I feel like just the projects that I've done on my own have taught me significantly more than any classes that I've taken in college. for sure. Like I'd say that probably 85% of my knowledge has just come from the things I've learned on my own,
Yeah.
and then the remainder 20% came from college. There are certainly some classes that helped here more than others. Like there was one class I took a couple years ago, CSE 611. It's advanced digital design. So basically an intro to FPGAs, learning the basics of system Verilog, all that sort of stuff. And that was the most helpful class for this because without it, I wouldn't even know anything about System Verilog. But that class was not nearly enough to get through a project like this. I still probably learned about 80% of the stuff that I needed for this project on my own and the other 20 from the class, you know. But I did absolutely learn things from school. It's just most of it did not come from that.
What other vintage computers are you particularly interested in, if any, too, that strike your
So
fancy?
yeah, so I'm most interested in just weird, unique stuff because, you know, as a hardware guy, I just like learning about weird hardware designs like nobody's heard of before and that are just poorly documented, didn't sell very well, just you know, just strange stuff. So that just kind of as a blanket statement would describe what I'm into. So that would be the Lisa. I have like this weird HP 9836 workstation thing from the like from 1980, 81, I think, that
Huh.
weird 68,000 based architecture with
Okay.
really good colored graphics, high resolution display. I just at VCF, I got this weird Zenith machine that has like both an 8085 and an 8088 in it, and it can switch between like being a CPM machine and a DOS compatible or PC compatible just by writing to a register. It can flip between the two CPUs. So, you know, just weird, unique stuff like that. And then I just got, I don't know if you've seen Usagi Electric's videos on the Wang Rider, but
Mm.
I got my hands on the actual Wang Rider that he had that he used in his videos. And so I'm planning on doing some experimentation with that. Also, you know, once again, weird hardware. Just anything strange is
Yeah.
cool to me.
I've always had a fascination with, yeah, strange machines, the
Yeah.
losers of the industry, if you
Yes.
somewhat. The dual processor one, is it a S100 computer?
Yeah, it is an S100
It's
computer.
a CompuPro or a Godbout?
No, it says Zenith. I have it right on the floor over here, actually.
Oh,
It
it's a
says Zenith.
Zenith.
Yeah, Zenith Z120. It was like a
Oh, yeah, yeah. I'm sorry. At first, I was thinking it was Xenix, but yeah,
no. I've called it a Xenix by accident a few times, but
yeah.
no, it is a Zenith.
Okay, because years ago I had just a turnkey, not a front panel S100 machine. It was a CompuPro,
Hmm.
and which is Godbout, and it had one of those dual processor cards in it. It had a
Oh,
dual
really?
8088 and 8085 in it, and
Wow.
I didn't really know how to do a lot of stuff with it, but
Yeah. No, this one same concept, but it can do like full color graphics using its own completely custom graphics interface. It's got a built-in hard drive controlled by an S100 card. It's really weird and unique, and we got full schematics for it, full boot ROM listing. So I want to
ooh,
experiment with it. And speaking of Xenix, I want to see if I can get a
back to the
Unix
Lisa.
variant. Yeah, I want to see if I can get a Unix variant running on it, perhaps, because it does have an 8088 in it. So
Well, also, how about on the Lisa? Have you tried running Isn't there Lisa Xenix or is another one?
yes, there is Xenix and there's Uniplus on the Lisa,
Okay.
two
Oh, I think you
Uniplus.
mentioned that in your presentation.
Yes.
You mentioned that with your reproduction, and this is getting a little bit technical, but it's good stuff. You've achieved cycle accurate performance, meaning the system thinks and acts exactly like the original. So why was this important to you? I think I know that
So
you want to make it accurate, right?
mhm. So one little note for the absolute purists who might call me out on this, cycle accurate has a little bit of an asterisk beside it, because, well, two reasons kind of. First off, just talking about when the Lisa FPGA is running at stock 20 megahertz clock speed, from the programmer's point of view, it is completely cycle accurate. Like everything you do is going to behave exactly the way it did on the actual Lisa. But if you start getting into deep logic analyzer probes, logic analyzer traces of like the very deep, subtle functioning of the system, there are certain things that might happen, you know, a clock cycle earlier or later than what happened on the actual system. Like a great example of this. my SRAM. I'm using an external SRAM chip that's a little bit faster than the original RAM and the actual Lisa. And because of how I designed the RAM circuitry, whenever you try and read from this SRAM, the data is actually going to be ready a couple cycles faster than it was on the actual Lisa. So depending on what you mean by cycle accuracy, that may not be cycle accurate because you'll see the data a bit quicker. But from the programmers and the 68,000's point of view, it's going to look exactly the same because the 68,000 still isn't going to read it until the same time that the original Lisa read it. So there is a little
Yeah.
nuance there. And then also the cycle accuracy kind of diminishes even more if you up the clock speed above the stop 20 megahertz. Because at that point, like it is truly, even from the programmer's point of view, not quite accurate to the original Lisa. Because when we go above that stop 20 megahertz speed, um, it overclocks all of the CPU and RAM logic and a little bit of stuff on the I/O board, but it's not overclocking the floppy disk controller because if you do that, then you can't talk to floppy disk properly. And it's not overclocking the COP microcontroller that has the Lisa's real-time clock and keyboard interface in it, because if you did that, the clock would run too fast and you wouldn't be able to talk to the keyboard anymore. So now when the CPU tries to talk to those, they're not going to respond as fast as the CPU is expecting. So if there's like a timeout loop that you have running on the CPU where it expects it to respond in a certain period of time, the CPU might time out thinking that the peripheral's dead when it's actually not, just because the CPU is running faster than normal. So the cycle accuracy dies a little bit when you start getting the faster clocks, but it shouldn't be a big deal as long as programmers keep that in mind, right?
So I know you probably talk to a lot of people who are technical and or they get it. They know something about the Lisa that they're asking you stuff because they're into it, right?
hmm
But how about when you now encounter people and they've never even heard of the Lisa, much less understand FPGAs or and basically they're asking you like why'd you do why are you doing this or how do you like what do you tell someone like that? They're kind of interested because they're like well that's interesting, but why is it interesting? You know what I mean? What do you tell them?
The quick like 5 minute summary or five second summary is I think the Lisa is cool and I think FPGAs are cool, so let's put them together. But in a little bit more detail, uh, just I want to make the Lisa more accessible to people because, as you know, they're not easy to come by, and even when you can get your hands on one, they break a lot, and when they do break, they can be very difficult to fix and keep
Mhm.
running. And if I can make a board that implements one inside an FPGA, it's going to be much more reliable than an original Lisa. And also, I've added a bunch of modernizations, like USB keyboard and mouse, HDMI video output, onboard hard disk emulation that just make it much easier to use in the modern age. So all this just allows the Lisa to be much more accessible to people, overclocking to, all that, just more accessible to people. People can do software development on the Lisa more easily, just experience what a Lisa is like more easily, and not to mention more inexpensively than an original Lisa. That's kind of the main motivation here.
If they ask you like what's so important about the Lisa, what do you say about that? Other than you're
Um,
fascinated by it, do you think of it as particularly important in computer history? I imagine you do, but what do you
yeah.
say to that?
No, yeah, I think it has a lot of historic value. Of course, there's the hardware side of things, which I could talk about that for a long time, just how neat the hardware and software is. But from the historic point of view, yeah, it is a really historic computer, just because of how much it did with the graphical user interface. Like, of course, people will always come to point out the Xerox Alto was first, and that it's what truly pioneered the graphical user interface. But
Yeah, Apple stole all of it.
yeah, Apple stole all of it, but there's always a comment like that whenever anybody
Yeah,
like makes a video about the Lisa or
I
says
know.
anything about it, there's always a comment that says that.
Right. Yeah.
But the thing is that if you put like a modern computer user in front of an Alto and then you put them in front of a Lisa, they probably wouldn't really be able to figure out how to use the Alto, but they'd
Right.
probably be able to figure out the Lisa because the Lisa took those concepts from the Alto and
Hmm.
made them much more intuitive and made them into what we expect to see today. Of course, there were some false starts, like the whole stationary concept that's a little bit weird, but
Yeah.
for the most part, the Lisa is what created and pioneered those same metaphors that we see in modern machines.
Yeah. Yeah, and also a lot of people don't realize, no, Apple didn't invent the mouse. They licensed it, just like
Right.
Xerox actually licensed it from what was Stanford, SRI, Douglas Engelbart's organization.
Hmm.
But they licensed, it was a three-button mouse, and like I say, much more complicated and pop-up menus versus pop-down, and they didn't really have windows like you think of.
Yep.
Innovating the one-button mouse, they almost made it too simple ultimately with the Macintosh, but that helped a lot of people learn it, as it and
Right.
then it evolved. Now, actually, at the recent show, you had three of them, didn't you, at your table?
Yes,
Three
I had
Lisas?
three, and then my friend Will, he brought a fourth one.
Uh, so you have
So,
three Lisas?
yes, I have personally have three Lisas. They're all sitting
Yeah, I
over
see.
here in my room, off to the side.
Very cool. You mentioned too that you may be working on what you call a Lisa Fit version. So obviously, all this hardware is going to stop working at some point, and here we are. I started collecting computers like 30 plus years ago, and back then you had to try to fix it and make it work, or just clean it up, and now of course there's a huge industry, if you will, of replacement parts, and obviously power supplies go out some of the first things, and then mechanical things like drives, disk drives and hard drives. And we pretty much have replacements for all these things for almost all the major personal computers at this point. So, and then, so at some point, you're not going to really, you can't have an all original old computer. You have to replace parts in it or have a reproduction. But talk a little bit about that Lisa Fit version. Do you think that's something you're going to still do?
Yes,
And what
I'm
about reproducing the
absolutely.
case? Like that, just the whole thing. What do you think?
That's a little bit outside of my area of expertise. We might want to leave that to somebody more like Mac Effects, maybe. But
Yeah.
I can at least do the board part. I can handle that aspect. I am absolutely still planning on doing it. I have a lot to do right now, though. So that's going to be for a little bit later on. I've got to get the current Lisa FPGA boards out the door. I have a giant stack of them over here that, well, they're not
I
showing up
can't
on
see
camera
him.
very
Oh,
well,
yeah,
but
I'm
I
kind
have
of seeing him a
a
little bit.
giant stack of them that I've got to
Yeah.
get out the door first and do a lot of stuff like that before I worry
Yeah,
about
hurry
the
up. I better let you
motherboard.
go. What are you waiting on? They're
Uh,
apparently in very high demand.
yes, that's the impression I get. They're going to sell out pretty quick. But yeah, no, that's going to be for a little bit later on once I get through a lot of this stuff, and then I've also got school to keep that in mind too. But no,
Nah.
I'm still planning on doing that. Luckily, it shouldn't really require any major changes to the code because it's still the same core Lisa, just a matter of like remapping and redefining some pins. The big deal is redesigning the board, right? We need to redesign the board and the form factor of the Lisa motherboard, which the form factor part isn't too difficult because I already have designed a Lisa motherboard, so I can basically just steal that layout and pop this hardware onto it.
So
But
this
then
one would be just like one board you plug into the motherboard.
this would be the motherboard.
Oh,
Like
okay.
it would just be a new motherboard that would
Oh, I
slide
got you.
in
Oh,
because you don't need any cards. We can just fit the whole thing on the motherboard. Why not? Yeah, but no, I would have to relay everything out and reroute everything on the Lisa motherboard. So that's the more time consuming part. This would be a more stripped down version compared to the desktop board that I have right now because I would probably omit things like the USB keyboard and mouse interface, HDMI, maybe the onboard hard disk and floppy disk emulators, things like that. Because
you don't want to
where
do that.
where are you going to put the ports, right? Like
Yeah, yeah,
we
I
only
got
have
it.
a certain number of ports on the back of the Lisa.
Yeah.
Where are we going to put those?
And I was
And
thinking that's why you have to do it the motherboard so that the ports come out the back properly, right?
yes.
And I wasn't thinking that at first, but
Exactly. The big challenge there, the only big challenge I'm thinking of is expansion slots because you can't get those connectors anymore. So what are we going to do? I guess just expect people to harvest them off their original motherboards. Not completely sure about that yet, but
so what I read or you talked about is you initially only planned to make a few boards and then you got so much feedback and demand and stuff. So this run you're going to send out is 50, right?
mhm.
And you're actually going to be selling them or they're through Mac Effects and Joe's Computer Museum are the two outlets.
Exactly. They're going to be split 50-50 between the two of them. And so same price on both of them. So it's basically just whoever you prefer to do business with. We're not trying to have any competition or anything here. It's basically just whoever you want to buy from, right?
Is the price already set? Or they'll
Um,
determine that or
yeah, tentatively we're going with $300. Don't hold me to that or anything because you never know. Something could
yeah.
change and like they want me to charge a little bit more or something like that. But I I'm going with $300 right now. That's what I'm going for. I wanted to make it cheaper, but just keep in mind like just the parts costs have gone up recently with like the AI chip shortages and all that stuff. Like FPGAs used to be $20 when I started this project. Now they're 50. And a lot of the other chips have increased
Yeah,
accordingly. So my raw costs have gone up a lot, and then we have to charge a little markup, for our labor costs. So
sure.
can't really go below that, unfortunately,
Are you
even though I
planning
want to.
on already planning on doing another run?
Yes, I am planning on doing another run because from the number of like signups I've gotten for the mailing list and for pre-orders, I get the impression that these are going to sell out probably within a couple days at most. So I am absolutely going to be doing at least one more order, probably more up until they just stop selling is the plan. Yeah.
Keep selling till you move into your new improved location and buy your luxury car.
Yeah, just keep on going until I'm a multimillionaire.
Um, oh, sorry, I meant to ask you this. So you touched on it. So with the Lisa FPGA board, you can plug in HDMI, modern USB keyboard, mouse. You could do wireless, of course, but you can also plug in the real Lisa keyboard and mouse. And basically, you've covered all angles where you can use new replacement drives, hard drives, emulate whatever, or you can plug in the real stuff like a vintage profile and so on, right?
Yes, I want to add those modernizations for people who want to use them, but I also want to still allow you to plug in all original stuff if you so choose, right? So no, yeah, original keyboard and mouse still work fine. Original profile, original floppy drive, really original Lisa display if you feel like hacking some wires into your Lisa, although I don't think anybody's going to be doing that. Yeah, basically original everything if you truly want it.
Someone's going to do it.
I'm sure somebody will. I probably will during my testing and preparation for getting the motherboard replacement working. I don't know if anybody else will, but I certainly will.
So again, you just did the show. So was it? It wasn't. It was 2 weekends ago, right? Was it last weekend, Dallas?
No, it was
Two
two
weeks.
weekends ago. Yeah.
We're talking on Friday, so I'll put this up pretty quickly. So that was in Dallas, the Vintage Computer Festival Southwest, and the whole Vintage Computer Festival thing is growing. There's quite a few. That's one of the newer shows, and the one I think in San Diego is one of the newer ones. Then there's a real established one in Silicon Valley, and then East in New Jersey and Atlanta. So are you going to any other ones this year?
I'm not completely sure yet. The nice thing about Southwest is that it's over the summer, so I don't really have to worry
Oh,
about, missing school or anything like that. I know I can miss school. Like, there's not really a problem with that. I'm just, a perfectionist about school. I never want to miss class or anything. But I know that it's fine to miss a couple days, so I really need to get in the habit of being okay with that. But people have been trying to convince me to come to Midwest, like to the point of even offering me like free tables and stuff, and
which is in
basically,
Chicago, the Chicago
yeah,
area.
yeah, basically free everything. Just show up and you'll have a free ride all the way through. So I'm strongly
Yeah.
considering that one, just given that.
So
So
that's
don't.
September 12th and 13th, by the way,
Yes, yes.
for
Don't be
everybody.
surprised if you see me there, but in terms of the other ones, probably not.
Okay. And since we're on
Yeah.
the subject, the end of July and August 1st and 2nd is Southeast in Atlanta, and then August 1st and 2nd is West, which is in the Computer History Museum in Mountain View, California.
Yeah,
So
West, I probably can't make it to just because of how big of a commute that is. It's, all the way across the country. Although I do love the Computer History Museum. That place is
you
pretty
can just
cool.
have a whole aisle for you and the Lisas on the airplane.
Fly them all. I mean, people have done. I've seen people strap leases into plane seats before when they
Yeah.
really want them to make sure they don't get damaged. But I bet that's super expensive. But no, Atlanta. I didn't realize the Atlanta one was over the summer. Maybe I can make it to that one. I don't know. We'll see. We'll see.
Yeah, because I was saying that's decent driving. That's not bad driving distance for
No, it's
you.
about three
Three
hours.
hours,
Not
probably,
bad at
maybe.
all.
Yeah.
I wonder. one perk of like Southwest and Midwest is that I would know people there. Like my friend Will always exhibits with me at Southwest, and then at
Okay.
Midwest, um, the Mac Effects guys would be there who I could exhibit with, and then Adrian would be there who I could also exhibit. Adrian Black would I could also
Yeah,
exhibit
because you
with.
helped him out with his Lisa. That would and he's in Florida, is that right?
No, he's in Portland, Oregon.
Oh.
Yeah, all the way completely
Where did
different
I
side
get
of the
that
country
idea?
there.
I don't know where I got the idea of Florida
I
then.
mean, Portland sounds kind of like Florida, I guess.
Yeah, what's the difference?
Yeah, what's the difference? Same place.
I was going to tell you this after our recording here, but I'm going to southeast, so I got to get these southwest. I was going to say slip out to southwest. So yeah, I'm going to the Atlanta show.
Oh, really? Okay, so
So
I
yeah,
would know
so
somebody
maybe
there
I'll see
then.
you there. That'd be
Yeah,
cool.
perhaps so.
So anyway, with that, I'll let you go. But it's. Do you think there's something else? Yeah, I'm the interviewer. I had a lot of good questions. Something I missed? Maybe we should have touched on. Anything else you think you should add about it, or?
I mean, I guess there was one question we didn't get to, the thing about open sourcing
Oh
it.
yeah, yeah, right.
Um,
Because I kind of jumped around. Yeah,
yeah.
here I think I have it, or you can just talk to it if you want. Oh wait, here it is. Despite selling the hardware, the project remains open source. Why was it important to you to put the design on GitHub?
Yeah,
Because you've always done that. You have other projects.
yeah, I always want to make all my designs open source because I just believe, just given my background of, starting all this stuff when I was a kid who couldn't afford anything at all, I just believe in making these sorts of projects as inexpensive and as accessible to people as possible, right? And open sourcing things is, in my opinion, the best way to do that because people can just build things directly instead of, being charged a premium for, labor costs or anything like that. They can just build it themselves, no headache, no nothing like that. And same, no exception with Lisa FPGA. And there's also the benefit too of if you want to modify things, make it your own, change the code in any way, design your own board. You can do any of that to modify it to your heart's content without any limitations or not being able to have access to the code or anything like that. And part of the reason I'm selling them here, though, is because in an effort to attempt to achieve that goal of making them as inexpensive and accessible as possible, this is actually one of the few cases where selling them is actually the best way to do that. Because if you order these boards yourself, it's actually going to be more expensive than if you buy one from me. Ordering them, it's bulk discounts are a big deal here. If you just order one yourself, you're gonna have to buy two of them at the very least. It's gonna be a little over $1,000 for two of them, so that's gonna be 500 a piece. Whereas if you order one from me, it's about 300. So that's part of why I'm selling them, to kind of still continue towards that goal.
Yeah, that's really good and it's excellent. But I'll also mention it's really good that you do both. It's also more beneficial because there's people like myself who I couldn't really order parts and put it together. I mean, I could, I guess, but not. It's not really my forte or whatever.
Hmm.
So at least it makes it accessible for me to be able to get one, and I'll be able to get it and start playing with it right away. And there's a need
Right.
for that too. There's people in the hobby, and they're not as technical as you are, or a lot of other people soldering down to even doing recapping stuff. I don't do that. That's the basics, right?
Yeah. Very true, very true. There are plenty of people who
Yeah,
don't know how to do that stuff.
yeah. Now
So
I could do it. I mean, I've got basic soldering skills and stuff, but it's good to have both options available. So I
yeah,
appreciate that. Yeah, because I know there's been other
absolutely.
cool things that have come out. Like even some years ago, I heard about your the boards themselves, and but they're unpopulated, and I was like, oh, who would I find to get all the parts and do it and da 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 and stuff like that. So
There have been a couple people who've paid me to assemble those for him actually, but it's just so much work for me that
yeah,
I've kind of stopped taking requests for that because even if they pay me very well to do it, it's just like, oh my God, this
yeah,
takes
and
forever.
that's not the fun stuff.
No,
Like
no,
it's fun
that's
the
not
first
even.
time, right?
Yeah, but then after that, it's just tedious soldering in like 50 sockets and like 50
Yeah, yeah,
resistors, and oh, I'm just ready to be done with this.
yeah.
Yeah.
Well, all right, man. Great talking to you. I really appreciate it again. And
Yes.
yeah, best
Thank
of
you.
luck. And you know, we'll be watching you. I guess
Yeah,
that's what
thank
they
you so
say in
much.
these kind of interviews.
It's been a pleasure to be here.
Yeah, I'm sure you
Great
have a
talking to you
great,
as
bright
well.
career ahead. So it's very
I hope
exciting.
so. I hope so. We'll see what
Oh
happens.
yeah,
Still a couple years before I get there, but we'll see what ends up happening.
yeah. A lot of people are impressed by what you've done. So,
Thank you. Thank you. I really appreciate it.
but all right, we'll talk to you again sometime.
Yeah. See ya.
Thanks for listening, and please check out some of my other interviews at classiccomputing.com.